Welcome back again. One more problem and its discussion from Pulley systems. It's taken from the book Concepts of Physics by HCVerma 27. And if you look at the diagram, there is a fixed pulley here, there is a string going around it. Here is a mass 5 kg, this mass is equal to 2 kg. And in addition to that, in addition to the weight of this mass and the weight of gas, there are two more forces, F, 1 Newton, acting on this mass M2 vertically downward, F, 1 Newton acting on this mass M2 vertically downward. Now, similar problems we have discussed in previous videos where these two forces were absent, these two external forces were absent, right? Now, and why? Now let us, to do it quickly, you can write the expression for acceleration straight away. Look, its weight will also be, in addition to this force 1 Newton which is acting on this mass externally vertically downward, its weight is also acting vertically downward. This is the weight. This will be your M2 times G. And similarly here, in addition to this force, another force that is acting on this mass M1 is its own weight that is also acting vertically downward. Let it write it as M1G. In the book, this is taken as M1, this is taken as M2, but in my previous videos, I have taken this as M1 and this as M2. Now, if you look at the diagram, this is the string that is going around the pulley connected to mass M1 here, M2 here. There is no force of friction here. The mass of the pulley is neglected. The strings are light, means the mass of the strings are also neglected. So here the tension is to this side for this mass, and for this mass the tension is to this side. Now, if you redraw the diagram like this, to quickly answer the expression for acceleration, this is your M2 is same thing as this, that is 2 kg. This is your M1 that is equal to 5 kg. Now, these two forces, I represent it here. This, your black one, that is 1 Newton, and its weight, M2 times G, its weight to this side is M2 times G. And in between the two masses, this is the string, or this is your string, and on this 5 kg mass, this black one, this is your 1 Newton force, and let me show the weight in red, and this is your M1 times M1 times G. So if you look at the system, by making these two horizontal like this, I have not added any extra mass or extra force to the system. And here is your tension T. This is an internal force, I will not consider. Now, if you look at the total mass of the system, is 5 plus 2, that is 7 kg. And the net force acting on the system, two forces on this side towards left, two forces on this side towards right. In fact, here, these two forces are down and these two forces are also vertically down. So, to answer it quickly, Look, this 5 kg, so this m1g will be more than m2g because this is 2 kg. So your acceleration will be, so your acceleration will be your net force over total mass, your total mass, and let me draw a line here. Your net force will be m1g plus 1 Newton minus of m2g minus of 1 Newton over total mass m1 plus m2, that is equal to 7. So this 1 Newton cancels. So we have m1g minus m2g over 7. So if you take g common, we are left with m1 minus m2 over 7 times g. Now m1 is given as, this is taken as m1 given as 5 kilogram, m2 as 2 kilogram. So 5 minus 2 over 7 times g. 5 minus 2, 3. So 3 by 7 times g. This is your acceleration, right? So now to find the tension, you have to write the equations. Now, so this mass 5 kg is falling down with acceleration 3 by 7 times 7 of g, and this is moving up with the same acceleration because the string connecting the two masses is not stretchable. If you want to write the equations, you can write the equations now and solve for acceleration also. Then what we have to do is, if you look here, t, the conclusion is, since this value is more than this value and both this 1 and 1 are same, so this will come down. So for this you write, for the mass m2 you write t, that is being opposed by m2g minus 1 is the net force on this, that will be its mass, that is 2 times acceleration. And for this one, this m1g plus 1 minus t is the net force on this downward, so that will be its mass into acceleration, that is equal to 5 times a. From here also you can have the same expression for acceleration. If you add it, your plus t minus t cancels, so you have m1g minus m2g. Now this also cancels. You have 5a plus 2a, that is equal to 7 times a. So your a comes out to be m1 minus m2 over 7 times g. Now this is taken as m1, 5 minus 2, that is 3 over 7 times. And to find the tension, you have to put this value of a either in equation 1 or in equation 2. Let me calculate, then I will come back to the second part of the question. Or you can just put it either here or here to find the tension. Let me do it here. So let me do it here. Put it here. T minus m2 times g minus 1 is 2 times a. I am interested to find a t. So 2a, this term and this term goes to the right hand side, plus m2 times g plus 1, 2. A we have calculated as 3 by 7 times G plus M2. M2 was given as 2 kilogram. M2 was given as 2 times G plus 1. So this becomes, so if you take so this is equal to 60 over 7 plus 2G plus 1. Add these two, you get LCM as 7. So 60 plus 7 twos are 14. 14G, this plus 1 here. This is equal to 20G over 7 plus 1. So that is equal to, you can keep it like this, no problem. That is equal to 20G plus 7 times this. This much Newton is the tension. Now the second part of the question is describe the motion of M1 if the string breaks but F continues to act. Look at this, is taken as your M1. If the string going around it, it breaks, means there is no tension. So in that case, what will happen to M1? Prior to the string breaks, this was moving up with acceleration. So when the string breaks, this mass will have some velocity to this side. Suppose the string breaks after time t. Means suppose the string breaks after time t. Means after time t means this was accelerated downward. This not upward. This was accelerated downward. So this has moved down by some distance and its velocity has increased for time t. So since acceleration is 3 by 7 and this was moving down with the same acceleration, this was moving up with the same acceleration, so its velocity and its velocity after time t will be using expression v is equal to u plus et. If both of them started with initial velocity u is equal to 0, so your velocity becomes acceleration into time after t seconds, that is 3 by 7 times g. This is the velocity. Now the string breaks. Means there is no tension. So the force acting on M1 is only M1G and this continues to act. So let me draw it here. Now the force acting on it, it's still acting on it, is 1 Newton and its weight M1G and its weight M1 times G. Now the tension in the string is no more there. So it is under the mass M1 is under the influence of the pull of the earth. Now when the string breaks after time t, its velocity is this much. Now its velocity is equal to this much, 3 by 7 times g, and and the force, and it is falling freely there. Now the acceleration part is not taken up. Now it is coming down. With acceleration due to gravity, that is equal to g, with the initial velocity this much. All right. So that is all about. Thank you. Means now you can say the force acting on it is this much. sorry, I made a mistake here. Now the velocity is this much. This is the force. This still continues to act, and this is also acting. So the force on it is equal to m1g plus 1, that is equal to its mass times the present acceleration. So your present acceleration will be m1g plus 1 over m1, and since the value of m1 is given as 5, so 5 times g plus 1 over 5. So this will be your present acceleration, because this is not falling freely. Had this been falling freely, then its acceleration would have been g. But in addition to that, there is a force acting on it. So once the string breaks, the tension part is removed, it is no more there. But this force continues to act, and this is also already there because it is falling. So the two forces acting downward after the string breaks is m1g plus 1, that is the net force. So that will be mass times the acceleration. So now the acceleration is m1 comes to this side, m1g plus 1 over m1. If I put the value of m1, so 5g plus 1 over 5 is the present acceleration, right? Thank you.